Welcome back, everybody. This time we're going to do things a little bit differently. We've got a live introduction from Stats Canada. They've got a very interesting presentation. Alessandro, if you could start your video and unmute yourself.
Hello, everybody. Hi, John. Can you hear me?
Yes, we can hear you very clearly. Thank you very much, Alessandro. Thanks for joining us.
Okay.
So go ahead.
Thank you. So first of all, thank you, John. Thank you, GeoIgnite, for giving us this opportunity to be here. You're doing quite an amazing job with this conference. Again, my name is Alessandro Alasia. I'm Assistant Director at the Center for Special Business Projects, which is a division of Statistics Canada, where I lead the Data Exploration and Integration Lab. At the Data Lab, we have a large portfolio of projects. Every year we have between 20, 30 projects, and a number of them have a strong geo component, either because of the data we use or because of the modeling techniques that we use and the analytical work that we do. So the focus of our presentation today is on some of these projects with a geospatial component. And our presentation is divided in four parts. The first segment is by Joseph, and we'll focus on a major initiative that we started a couple of years ago. It's called Linkable Open Data Environment, and the objective of this initiative is to bring together and harmonize open microdata, mainly from provincial and municipal sources. So we started to release a number of databases, open databases, and Joseph will describe the overall architecture of this initiative. The second presentation by Marina is specifically on one of these open databases, the open database of buildings. And her presentation will show how working with open data is really enabling us to collaborate with a number of stakeholders. She will describe these collaborations. And the third segment of our presentation is by Nick, and it's on a project that we have done with the Canadian Mortgage and Housing Corporation, CMHC. It's about a set of proximity measures and a data viewer that we have developed for CMHC. And we have released on the Stats Canada website in April. The measures are about proximity to services and amenities like grocery, pharmacy, proximity to employment, proximity to transportation, public transit, etc. And those measures were developed at the dissemination block level. So as you can imagine, there was a lot of geospatial analysis and a lot of data crunching that need to be done. But the results is a database with a very high level of granularity, because the dissemination block is essentially a block in urban area. And that was done for all of Canada. So it's the first really comprehensive data set on proximity measure across Canada. And the final presentation, and I should mention for this initiative, for this project, we use both Stats Canada data as well as some of the open databases that we developed for the Linkable Open Data Environment. So again, it's a mix of Stats Canada holding and open data, which again shows the relevance of working with open data. And the final presentation by Ala is about a very cool project, an R&D project. It's about estimating building height using street view imagery. So this is a different type of imagery. It's not from the sky, satellite imagery, it's from a street view. So there is a lot of advanced image processing involved in this analysis, but as well a lot of geospatial analysis, and Ala will illustrate that. And the purpose of this project is in fact doing an estimation of building height that can be incorporated in the open database of buildings. So it's really adding a third dimension to a database that is now two-dimensional. And again, the goal is to release this information as open data. So I stop here. Again, thank you so much for this opportunity to present this work, and I'll pass the microphone to my colleagues for the four segments. Thank you.
Thank you, Alessandro. Okay, I'm going to switch over to video now. Just give me a second.
Hello everyone, my name is Joseph Pukar and I'm here to talk to you about the Linkable Open Data Environment, so let's get straight to it. For a bit of context, StatCan is a regular producer of open data, mainly aggregate data, such as statistical measures released at the national or provincial level. There is an increased demand, however, for granular data. For various reasons, we're usually not able to release a lot of granular data, a lot of their data coming from statistically sensitive surveys and things like that. There is a wealth, however, of open microdata available on the internet for many cities and provinces across Canada on a variety of themes. So some of this data is complementary to StatCan's internal data holdings. For instance, open business data I can download and compare to StatCan's wealth of business data that we have internally. But a lot of this data we can download actually has no analogs inside the agency and can be used to fill existing data gaps. This leads us to the Linkable Open Data Environment, or the LODE, an initiative we've been working on for the last few years. And these are the four pillars of the LODE. First is openly licensed microdata. So the idea is we collect open data, we clean it, we standardize it, try to add some value, and we re-release it under the Canada Open Government License, which is a very permissive open data license. The second pillar is open tools. The idea is, we use open software as much as possible, for instance, QGIS, but also we try to make our scripts available and try to work as much as possible in an open space. The third pillar is collaboration. So open data, of course, makes it much easier to collaborate with people outside of the agency, and we make an effort to take advantage of this. And the final is the LODE viewer, which is actually under development, but soon to be released, a web map application where we can actually view a bunch of these data sets that are under development. So this is an overview of the LODE, the different data sets that make it up. So we have an open database of buildings, educational facilities, healthcare facilities, addresses, businesses, infrastructure, cultural and art facilities, including things like museums and libraries, and recreation and sport facilities, including things like community centers and arenas. And all these happily revolve around the central LODE element. And we can think of this as a set of scripts for linking data, or maybe an API for linking the data. It's a concrete example. Let's say that I have an open database of addresses that has coordinates associated with street numbers and street names and cities and so on. And I also have an open database of buildings that has building polygons in space. Well, I should be able to associate those coordinates with those buildings. So now I have a building associated, or multiple buildings associated with an address. Similarly, if I have something like an open database of healthcare facilities, well, I could say, well, this address is a hospital. And now that hospital is associated with that one or multiple buildings. That's kind of the end goal here. So this is the current state of the Linkable Open Data Environment. We have 3 releases. We have the Open Database of Buildings, now in version 2, an Open Database of Educational Facilities, version 1 released in August 2019, and an Open Database of Healthcare Facilities, which actually was just released this past April. So I don't have time to go into all of these, unfortunately. Marina will be going into the ODB in some time, so I'll just talk briefly about the Open Database of Healthcare Facilities. This is a compilation of data from provincial, municipal, and federal sources, and even a not-for-profit. We received some data from the Canadian Institute for Health Information, CIHI. This data set has over 9,000 entries in it, which we've classified as either ambulatory care services, hospitals, or nursing and residential care. So the idea is we take all the data, we clean it as well as we can, we map it to standard columns, then we add a new type and try to assign everything as well as we can to this new type. So we also retain the old type information from the original data sources, but we try to make it all consistent with new types as well. So this data includes the name, address, latitude and longitude when available, and also census subdivision when we can. Open tools, so the most important of which is Open Tabulate. So this is an open source Python package we developed to more easily process open data into a standard format. And the idea here is, let's say I download a CSV that could have any given names for its columns. Well, Open Tabulate allows me to read in that CSV as well as a JSON file with a dictionary mapping to say, please rename these old columns into these new columns, and also has some address parsing functionality. So this is available on the Python package index here, and also on GitHub. Speaking of which, we're on GitHub. Please come check us out. There's the link. This is also where we store the sources we use to build our open databases, as well as some of our processing scripts. Future plans. So version 1 of the Open Database Healthcare Facilities was released quite quickly to accommodate a growing request for health data in response to the COVID-19 pandemic. We would like to release an update to this where we do a little bit more data cleaning and deduplication. So this is going to be coming in early August. Other databases, we plan to release the cultural facilities and sport and recreational facilities databases this coming fall. And of course, everything else is under development, and you can check it out on GitHub. Thank you much for your time. And that's it.
Thank you, Joseph. My name is Marina Smales, and I'll be going further into the Open Database of Buildings, which was the first published data set within the Linkable Open Data Environment. We collected building footprints from municipal and provincial open data portals and standardized them by paring down to a set of universal variables. Some of the variables include latitude and longitude of the centroid of the building, the area and the perimeter of the footprint, and the census subdivision where the building is located. Our most recent version was published in 2019 with 4.4 million building footprints. Our goal has been to take this data set and enhance over time in a few different ways. First, by improving the open database of buildings within itself, by adding new variables, and then we are also looking to create new spatial variables using the data set, and as Joseph mentioned in his previous example, integrating with other databases in the Linkable Open Data Environment. One of the core components of the Linkable Open Data Environment is, of course, open data. This allows us to share easily with partners and make accessible to many users. One of our collaborations was with Microsoft, where we provided the Open Database of Buildings as a training data set for their machine learning algorithm, which they use to extract building footprints from satellite imagery across Canada. So they created an openly licensed data set of 11.8 million building footprints across Canada, filling some of our ODB data gaps that involved areas that were more remote and didn't have open data of building footprints at the time. We've also collaborated with several post-secondary institutions, notably Fun & College and the University of British Columbia. These projects usually take place over the course of a semester and give the students a chance to work with the government, explore data that is messy and not yet completed. There's still many things to discover about these databases, and it gives them a chance to take ownership over a specific variable or analysis of the project. So, for example, some of the outcomes that we've had from these collaborations include looking at adding more variables to the data set, such as each building's proximity to another building, or looking at more disaggregated spatial statistics, such as the density of buildings within a given area, such as a census subdivision or a dissemination area. We would like to expand the ODB further by adding variables. My colleague Ala will be presenting later to talk about adding building height to these building footprints. We'd also like to use the ODB to create some disaggregated spatial statistics, like I mentioned, building density within a dissemination area, and other ones as well, one of which I will show an example in the next screen. The example is our visualization prototype, which is on our GitHub page, and you can access this yourself using the link. I will show you a screenshot here. Basically, we are looking at the variable of population to building ratio. So how many people are there per building within a given area? In this case, we have selected dissemination area. So you can see there is a rectangular dissemination area in purple that has more than 20 people per building in that area. On the ground, this looks like a tall, densely packed apartment building, whereas the area to the right of this dissemination area is more medium-sized apartment buildings, and the area to the left, which is even less dense, is a mixture of kind of low-rise buildings and apartments and other houses. So this gives you a sense of what a potential visualization can look like at the neighborhood level. This is an area just west of Ottawa and just north of the highway. And we're still working on a final version. This is still a prototype, but we look forward to sharing updates as the project continues and publishing a version 3 sometime soon. Thank you.
Hello, everyone. My name is Nick Newstead, and I'll be providing a brief overview of the proximity measures that we've developed at DEIL. I'll quickly take you through why this project was undertaken, some of the details of the project, the methodology and implementation of the measures, and the results. So why are proximity measures relevant? Well, location remains an important dimension of economic and social outcomes, even in an increasingly globalized and digitalized world. Furthermore, nationwide measures of proximity did not exist until now. This was a cost recovery project with CMHC. We implemented measures for 9 different amenity types across Canada. They're developed at the dissemination block level, so DBs are the smallest census geographies, about the size of a city block in urban areas and considerably larger in less urbanized areas. And we released a database and data viewer in April of this year. We modeled proximity using a gravity model, which in its simplest form accounts for 2 dimensions, mass and distance. Mass can be thought of as the quantity of the amenity that is available at the location. For example, a large hospital likely provides a larger number of medical services than a small clinic. Thus, an ideal measure of mass would take this heterogeneity into account. Meanwhile, distance quantifies how far apart the origin and the destination points are. As the distance between the 2 locations increases, all else equal, the access the origin has to the destination falls. We can express this mathematically like so. I won't have time to delve into the specifications of the model today, but this is detailed in our upcoming methodological paper. So what does this look like in practice? Suppose we want to know how close my home is to grocery stores. We have my house, the origin point, denoted by this purple house. We've also displayed nearby grocery stores, which are the destination points, the underlying road network, which is represented by this grid, and a river that runs nearby my house. Of course, not all grocery stores provide the same level of service. For example, a convenience store versus a large grocery store. We can account for these differences by finding a variable that quantifies the level of service they provide, say revenue, for example. So imagine the size of these blue dots representing how much revenue is generated at each grocery store location. And we can see that some locations generate much more revenue than others. Well, suppose that I'm only interested in grocery stores within 3 kilometers of my home, as I'm unlikely to travel further than that for groceries, which is represented by this black dotted circle. The easiest way to determine the distance from the origin and destination points is to find the geodesic. This is the as the crow flies distance. For each grocery store, we divide the mass by the distance from the origin point to the respective store. We sum these up for all grocery stores within the specified buffer and call this the proximity level of my house to grocery stores within 3 kilometers. However, we haven't taken the local geography into account. If instead we look at the road network distance, we get this. So here we have our new buffer following the road network. Our distances are now snapped to the road network, and we've lost access to the grocery store across the river. The proximity level calculation remains analogous, however, it more accurately models how people in the area travel. So these are the types of amenities that we looked at. We used multiple sources to measure the presence and size of these amenities. 5 were created using Statistics Canada's Business Register, a continuously maintained central repository of businesses and institutions operating in Canada. The remaining amenities were derived from open data sources, such as GTFS feeds in the case of transit, or from other authoritative open data sources. Approximately 2.6 billion road network distances were calculated using an Azure-hosted instance of the Open Road Service API. And I'll quickly show you the data viewer here. So here we have Ottawa, and we're looking at proximity to employment, and we can see the map is fully interactive. So we can zoom in and we can see that downtown Ottawa has the highest proximity to employment, and the further out we go from downtown, we see less and less employment. We can also look at other indicators here, like healthcare, primary education, and we can also search for municipality up here. I highly recommend that you take a look at the data viewer if you're interested, and this concludes my brief overview on the proximity measures.
Hello everyone, my name is Ala Al-Habashna. I'm a computer vision researcher at the Data Exploration and Integration Lab, and I'm going to talk about an R&D project which is about building height estimation from street view images. Openly licensed street view imagery is spreading rapidly, and such imagery provides remarkable opportunities to enrich existing data on buildings with complementary information relevant for further economic and spatial analysis. Building height is a key information to enhance economic analysis of building footprints. And in this R&D project, an open source system is being developed for automatic estimation of building height from street view images using deep learning, convolutional neural networks, and advanced image processing techniques. For this system, street view images as well as other 2D building data such as the latitude, longitude of the building are needed. Google has been used for acquiring test images, and OpenStreetMap has been used for geocoding. The Google Street View Static API provide access to Street View images through HTTP requests. Also, the Nominatum API, which is an OSM-based API, is used for geocoding. There are other Python tools has been used, such as the OpenStreetMap Python tools, to acquire other two-dimensional building data. After acquiring the building image and the needed information, measurements of the building in the image are needed. Before that, we actually need to detect the building in the image, and for this purpose, I use semantic segmentation. Semantic segmentation is an advanced image processing technique, and what it does, it partitions the image into meaningful parts and labels every pixel in the image with a certain class. And nowadays, deep neural networks are usually used for this purpose, and in particular, a specific class of deep neural networks called convolutional neural networks are used to achieve this purpose due to their efficiency and accuracy. A TensorFlow-based convolutional neural network is used to apply semantic segmentation on the input image, and this image here shows a sample of the output of a convolutional neural network. As we can see, the result is a segmented image with the pixels associated with the building shown as green pixels. After semantic segmentation of the input image, the dimension of the building in the image is needed. For that purpose, an algorithm has been developed first to detect the roof line of the building in the image, and then another algorithm was developed to detect the bottom edge of the building in the image. And from these lines, the building dimension in the image is extracted. Afterwards, other parameters needed for building height estimation are automatically fetched from different sources. These are parameters such as building location, camera location, and then the distance between the building and the camera is calculated. And this is then used in the camera projection model to estimate building image height. This slide shows a sample of the obtained results. The figure here shows an apartment building in Ottawa, Canada. The actual building height is about 40 meters, and the estimated height by the system is about 38 meters. The results can be printed to the console for now, but when the system is implemented on a large scale, such results can be sent to a database or a CSV file. Currently, the system is being tested and the scalability of the system is evaluated. Afterwards, the system will be improved to further handle some challenging cases, such as images with the sharp angle of view. Thank you.
Welcome to the Q&A portion. I'm very excited to introduce the, well, they've already introduced themselves really, the StatsCan team. I'd ask you guys, did you want me to lead on the Q&A questions, or did you guys want to lead on them your own?
I can start, Jonathan. It's Alessandro here.
Great.
Can you hear me?
I can hear you.
I cannot start my video for some reason, but if you can hear me, that's good enough. I
think you should be able to start it now.
There you go.
There you go.
Thank you. So there are 3 questions. I see 3 questions. I can start addressing this very briefly. The first one is about how can the LODE data, Linkable Open Data Environment data can be used in community mappings and in combination with crowdsourcing. I really hope that this will be done, and certainly it's possible to do that. A long-term vision of our initiative is to make the database a little bit more interactive in such a way that we can have feedbacks about possible corrections that needs to be done by user. This is a long-term vision, of course, and require quite a lot of technical work at our end. But in the meantime, I think there is a possibility of downloading some of the data. If some community group is interested in part of a small part of the database that we produce, we can always support them and help them extract the data that they need. About the 3D mapping of building and the interior, mapping of the interior of building, I don't think that's part of our plan at this point. Again, there are a lot of privacy consideration and sensitive consideration when you go when you think about mapping interiors of buildings. So I think that's not for us, but you can certainly use the building footprinting and the work that Ale is doing on generating 3D buildings to further enhance that database. And then about the ground truthing, again, we are using the available information at this point. We are doing a lot of validations using some of our information at Stats Canada and using open information on the web. But again, it would be nice to in a second phase to have that interactivity capacity for the database to get feedback directly from the users, because of course when you use microdata and geocoded microdata, there are continuous development on the ground, changes, new buildings that are built or demolished, so there is continuous change. So having this possibility of crowdsourcing and interaction, it's a very valuable input, and would be a very valuable input. I stop here.
Maybe I can add a little bit onto the question about 3D maps with interior and exterior attributes. A lot of interior attributes might be a little bit outside the scope of the current project, but one aspect that could potentially be included is, of course, looking more at these buildings in terms of what type of businesses are within them, usage. That could be potentially something that we could include in terms of multi-use buildings and that kind of thing, because some of our future work looks to look into different data sets such as cultural facilities, etc. Some of these locations can have multiple purposes in the sense of a community center or other things. So I think some of the more maybe residential ones are outside of our current scope, but there is potential possibility to have some further interior information in terms of businesses and facilities and resources in those locations.
So there is one for me, I think. Let me see. For building height extraction, could your algorithm methods also determine the height of the first floor above ground level in addition to the total height? Well, that's not in our in our plan now, but this is with more analysis and more segmentation of the images. This is certainly something that is doable. Maybe by segmenting the extracted pixels of the image into floors using maybe windows or any lines. So it depends how many borders available in the image between floors. One thing that at the top of my mind is maybe using the windows, extracting windows, and then using this to find the number of floors in the building, and then use that to extract the height of the first floor. So that's a good idea we might consider for future work.
Okay, I can address the question of Luke and Ramiz about the building footprint. I know that there is quite a lot of interest in this layer. We don't have any specific collaboration with the provinces other than we use some of that open database. I think there is one that is produced at the provincial level, but we definitely would like to enhance this collaboration with provinces. We recently started an engagement activities with all the open data provider, contacting all the municipal and provincial open data providers. So we're definitely open to this dialogue and continue to do so. With respect to the validation of building footprint, again, we use the municipal and provincial data, so that is expected to be quite accurate. And the feedback that we got on the open database of building is that the footprints are actually very accurate. They are open, they have been used extensively or downloaded by the OpenStreetMap community and checked in all possible way. And all the feedback that we got is that this is very accurate. It's coming from municipality and provinces. But of course, there are continuous changes on the ground, so it's not always up to date. The work that Microsoft has done is amazing. It's a mapping of all the building footprint for all of Canada from satellite imagery. So it's the result of modeling. So of course there are inaccuracy and imprecision there, but that's the normal work result that you get from processes. So the approach, in brief, the approach that we use for the open database of building is start with what we have and improve on that. The other approach could be start with consultation, how we do that, and in many months have some results. We decide to go with something that is not perfect, but is fairly good, and then continuously improve on that. Thanks.
I'll take the proximity to public transit question here. So we did use network analysis for this. We used a walking network with OpenStreetMap data. So note this isn't actually traveling on the transit network, but it's walking to stops or stations where you can access public transit. As to relating this to housing data, this was done with CMHC, so I would imagine this is something they're very keen to look into as to whether these proximity variables are related to housing information.
There is another question about the building height estimation project. Have you considered using the existing sources of stereo imagery data available through various Government of Canada sources to drive building heights or other open data sets such as open LiDAR? So these sources of imagery, or these types of imagery have always been used by other organizations in the past for building height estimation, and the only issue with such imagery, we haven't done it so far at the DEIL, but the concept or the idea of using street view imagery is that they are widely available nowadays. There are different platforms that provide this type of images nowadays, and they can be really utilized on a very large scale, like on a scale of cities or a country, due to their availability, and they are available, with different kinds of terms and condition use. But there are some platforms provide them as open source. So due to this reason, we started working on this project for OpenStreet, for estimating building heights from street view images.
So it's Alessandro again. There is a question about participating to a webinar as part of GIS Day from Bettina. Absolutely, we are absolutely willing to participate to event, or discuss in more detail our work, provide support if you want to use this database. So you can contact me or my team, and we'll definitely follow up and be happy to present or participate. Thank you. And well, there is a technical question about PyPy from Madi. I have to get back to you on this one because our developer of this code is not with us today. So I'll have to get back to you on this one.
I can add some more context to a question about monitoring open data sources and whether they're actively updated or defunct. Most of our work so far has focused on providing context in the metadata about where and when our sources were collected from these open data portals. In the early days of this project, we were, again, mostly focused on getting a product out there, even when some of the dates from the different data providers really did have a bit of a mismatch. And so, we would have some cities where they had last updated in 2018, and then others who update monthly. And it really depends on the resources that that particular open data project has in the moment. And so we do try to include everything that we can, just because our motto is kind of something is better than nothing, even if all of the most up-to-date versions are not are not available in every case. But every time we release a new version, we do try to collect as much information as we can. And in the future, of course, as we release more regularly or provide more updated ones, we do try to provide more updated data sets. So that is something that does require some manual monitoring. And when we're creating the metadata, we have a list that records every single time when we access the data files and which data files they were and when the source provider says that it has last been updated. So we provide that in the metadata.
Yeah, and there is a question by Kevin about the fact that there is a lot of capability in to leverage Earth observation imagery and LiDAR data in Canada, but very little of this was considered in our work. Is this a missed opportunity? Probably, but the fact is that we really want to focus on municipal, provincial, and other authority open data sources, and the focus is really compiling this information. We would be happy to work with other imagery or LiDAR that is all open and that we can use as well. And again, it's part of the development of this project. Keep in mind that we started less than 2 years ago. The first open database was released in, I think it was November of 2018, and was the open database of building. Again, it was an experiment at the time, and then it grew from there. So there's still certainly a lot of possibility to leverage this information, and we're open to suggestion for sure. And then, okay, there is a question from Heather about I think it's referred to the geocoding that we're using or have used. I think particularly for the building height estimation. So again, at this point, the solution that we have adopted are really driven by scan of what is available. So I think Alan maybe can elaborate on that. We use Nominatim for to geolocate the information that he was using for his model. I think we'll look also at OpenCage and Pelias, but there were other obstacles, particularly for Pelias. So we decided to go with Nominatim, but those are still activity in development. Maybe Ala can elaborate on this a little bit more.
Yeah, so for the geocoding, there are different APIs available out there. In my case, I've used the Nominatim for geocoding and reverse geocoding. You can, it's very comprehensive API, at least for the area I'm considering, which is Ottawa. You can get many pieces of information about buildings using the address or maybe the name of, if it's somehow like you can request with the name of the shopping center, you get the location and the different nodes around the boundary of the building, which is very useful in my case. So as Alessandro mentioned, the other APIs I've used also, they are like OSM based, such as the OSM tools. These are all available like with the clients in Python, which is the system I've used to build every single piece of the automatic system for building height estimation. So these API are found very useful, and but there are other APIs also available, and they can provide results with good accuracy. I have colleagues at the DEIL lab. I have a colleague who provided actually more specialized in geocoding APIs, and he recently wrote a profile about, a report about available APIs.
Well, Sorry to stop this great Q&A with the Stats Canada team, Alessandro, Marina, Alla. Thank you so much, Nick. Great presentation, great follow-up questions. We're so happy to have StatsCan with us for GeoIgnite, not in person like last year, but certainly online and engaged.
Thank you so much.
Thank you very much.
Thank
Thank you.
So we're going to be going to a short break. Hey, Nick. We're going for a short break, and we're coming back with I think what is going to be one of the absolute best talks of the conference for GeoIgnite to wrap us up. We've got June, the CEO, the president CEO of PCI Geomatics. I've been looking forward to this talk for the whole conference, so I hope everybody sticks around. And thank you again, Stats Canada, and you can get, please, go into the Slack channel, and we'll see if the StatsCan team can jump in there if there's further questions. All right, thanks everybody. See you soon.
Thank you. Bye-bye.
Thank you.